should know that power equation. For single phase, the power equation is P is equal to VI cos phi. You know the term. What is P? What is VI cos phi? This is for single phase. Then three phase. P is equal to root 3 VI cos phi. P is not known. So what is P? Power. Power is equal to, then what is V?
Voltage.
What is I? Current. Cos phi? Don't know. Cos phi, that is a power factor. PF. We will call PF. Technically, inside and out, nobody says cos phi or power factor, they will say PF.
Power factor.
The unit of power. Anybody?
Right.
Watts. The unit of V, voltage, volts. Unit of I, ampere.
Chalk piece is there in the box if you want it.
Ampere. So power is equal to VI cos phi for single phase. Then root 3 factor will come for three phase. Root 3 VI cos phi. Then cos phi, power factor in industrial, residential, commercial, the power factor will be 0.9. It's a basic term.
0.85 or 9?
85 or 9. 9. 1 is ideal, but we can do that 1. 0.9, that is a standard value. Then, what is hertz? You know hertz. Unit of frequency. In Indian standard, we are getting this power. At what frequency? Frequency, that F. Frequency is equal to 50 hertz. And everywhere in India, that is 50. In distribution side, the frequency is 50 hertz. In electronic power circuits, it may vary. For electronic, it may vary. Hertz will vary. So, electric frequency is equal to 50 hertz in India. It's IS standard. Okay.
Now you can tell about how the power connection needs to be obtained. What is the procedure? Temporary power connection, and there is a difference, no? Temporary power connection and the permanent power connection. After then you can explain about for a 3 BHK unit how the power is calculated, or 2 BHK.
So like civil, the designing is reverse. Same in electrical, the design is reverse. First we need to know the load. What is the load? Load means it is in watts. Load we need to calculate, then we need to go reverse for the design. For this load we need to calculate the size of cable. Then for giving that power to this cable, we need to calculate the protective equipments like MCB, ELCB, RCCB, MCCB. You know that?
They don't know, you need to explain.
MCB means miniature circuit breaker. Then RCCB.
What is the purpose also you explain? Yeah.
RCCB means residual current circuit breaker. That is RCCB. Then ELCB. ELCB means earth leakage circuit breaker. Okay. Then MCCB, molded case circuit breaker.
ಇದೆಲ್ಲ ನಿಮ್ಮ ಮನೆಯಲ್ಲಿ ಇರುತ್ತೋ. In your distribution board, if you see, these are the things available.
Okay. Then miniature circuit breaker. In this category, we will get 6 amps, 10 amps, 16 amps, 20 amps circuit breakers. What is the purpose of that MCB? For example, if 6 amps MCB, we are connecting some equipments to the 6 amps MCB. If the load is more than 6, if the power consumption, that current flow is more than 6, then it will trip. It will disconnect the circuit. We know that in a short circuit condition, the current flow is very high, infinity. We can say it as infinity. So that condition, that MCB will tell. In that MCB, it will mention in how many milliamps it will tell, milliseconds it will tell. So that is the purpose of MCB. Then RCC, it will be 32, then more than that. RCC means residual current circuit breaker. If the condition like residual current is flowing through any apparatus, then it will immediately tell residual current inside that apparatus that is flowing in the sense it will trip that circuit. Then ELCB. ELCB means earth leakage circuit breaker. Commonly we will use ELCB in kitchen because we are continuously operating that mixie blender or the
5 pin this thing, na?
5 pin.
Equipments,
So,
microwave oven, all the things.
So in kitchen it's very chances to get electrocuted. So ELCB come into play. If any earth leakage or some person is touching in that phase, then earth will resist that current flow. Then immediately the ELCB will ready. So MCCB, the higher version, if it is MCCB in the sense 32 amps, it's closed. Then MCCB will come for more load. MCCB will older age circuit breakers more than 100 amps, 200 amps, 250 amps. Like this it will come. Okay, these are all the term. Then selection of one wire. See, we will call electrical engineer, we will call conductor. In industrial commercial, we will use multi-stranded wires. Then underground cables. How we select these cables? See, for example, in this building, in this room. So, for the safety purpose, we will select like PVC insulated cable, then low smoke cables. So these are the categories of cable. PVC insulated, then smoke resistance. These kind of cables we are using.
Yesterday we have seen in fire safety they have given low smoke cables to be used.
Commonly we are using circuits. The thickness of
Some of the things will be mandatory, na, as per the fire norms.
Yes, it's mandatory. Then for looping circuit, I will say consider it's a DB. You know DB. It's a DB. I have mentioned that. It is distribution box. Okay. Then see that it's a meter box. Meter box, DB, then switch control, then equipment. See, for the residential project, we will connect some UG cables, underground UG cables means underground cable to the meter box, where we will keep meter, whatever meter, then some protective equipments. Fuse carrier we will use as a protective carrier, or MCB we can use. So from the meter box, we will connect the outgoing supply to the DB. This is called submain. Submain. It's a main incomer from external. Then we will connect it to the meter box. Then we will connect it to DB. Then switch control. Then equipment. This is a simple residential. We can say it's a one-line diagram. One-line diagram in electrical terms we will call SLD.
SLD they will call as SLD, single line diagram.
So we will start from here. Meter. How we will get 1 meter for residential? It is not for site purpose, it's for residential. So permanent meter, permanent power connection, we need to get it from electricity board. In Bangalore we will call bus com. From bus stop we will get that later. How? We will give some estimate. We will give the blueprint of that particular villa, apartment, anything.
ಡ್ರಾಯಿಂಗ್ ಅಲ್ಲಿ ಕೊಡಬೇಕು, ನಿಮ್ಮ ಪ್ಲಾನ್ ಡ್ರಾಯಿಂಗ್ ಅಲ್ಲಿ ಕೊಡಬೇಕು. ಎಲೆಕ್ಟ್ರಿಕಲ್ ಕನೆಕ್ಷನ್ ತಗುವಾಗ.
We will give some Tata copy, some formalities and then PAN card, photo and identity proof of that customer. After submitting all these things, they will approve that estimation. Then they will suggest 3 kilowatt meter or 5 kilowatt meter. More than 3 kilowatt, go for 3 phase.
Depends upon the size of your unit.
If the power requirement is less than 3 phase, 3 kilowatt, then go for single phase. The power requirement is more than 5 kilowatts, go for 3 phase.
What is single phase and 3 phase you explain?
If one circuit contains phase, neutral and earth, this is called single phase circuit. Single phase circuit. Phase,
Neutral
and earth. The voltage between phase and neutral will be 230 volt. Voltage between phase and neutral. Then 3 phase. 3 phase in the sense 3 phases, 1 neutral and 1 earth. We will denote as R, Y, B, D, then ground or earth.
See, in big projects, electrical engineer will be there. He will be taking the design and execution. In small projects, the civil engineer only has to do. The electrician will come and he will tell the, sir, 3-phase wire break. You should know what is 3-phase and single phase. On the time, sir, whatever money is there, if you give to the electrician, he will do according his own this thing. Engineer should know if you are doing a small project or any where the electrical engineer is not there, but you are the in charge. You should know, na? Otherwise, whatever he is asking, you are giving the money, that is not correct. Na? For that only, today the orientation is there.
Okay. 3 phase circuit in the sense R phase. The 3 phases it will come, 1 neutral circuit as well as 1 earth. So, I will say.
In any project, electrical component is around 15% of the project cost. Yes. That is also playing a major role in your project costing.
In that 15%, we will calculate the materials, make of materials. So the total overall cost will be inside of that 15%.
Roughly 15% will come. On that you have to work.
So R phase, red phase will be there, yellow phase will be there, blue phase will be there, then black is the neutral and green is the earth wire. This is the color coding. For 3 phase, red wire will be there, yellow wire will be there, blue wire will be there. It's the color coding for 3 phase as per IS.
You should use as per the color codes only. You can't use as per your wish and all. There is a mandatory. This color unit engineer needs to wear white helmet, means white only you have to wear. Like that electrical, what are the color code is given, that color code is mandatory you need to follow.
Okay, 3 phases will be there. Red phase, yellow, blue. Then black will be the neutral and green will be the earth. So voltage between 2 phases. What will be? What is the voltage between 2 phases? 440 volt. Voltage between single phase, that means one phase and neutral will be 230 volts. So you need to keep in mind. So see here. So you know the differentiation between single phase, how much wire it will come, then 3 phase. Then we will go for that. This section, meter box. So, after giving all the document, then estimation got approved. So, that licensing vendor, that is called this kind of operation, will do licensing contract. This kind of
all the approval things and all, one consultant will be there. In any big projects, one consultant will be there. Otherwise, you need to approach directly. If there is no consultant for small projects, you can apply online also, or you can directly approach the EB assistant engineer. You can give your application and go for the. If it is a big project, there will be a consultant. You give to them. They will handle all your files. Okay.
Then this kind of job, that one contracting company having that contract license, they will do this up to this part.
ಲೈಸೆನ್ಸ್ ಇರಬೇಕು, ಎಲೆಕ್ಟ್ರಿಕಲ್ ಲೈಸೆನ್ಸ್ ಇರಬೇಕು.
Then this for licensing contract.
Anyone can't go and do the things. Electrical, their license they have to obtain. Certified electrical.
Instead of this meter box, one single or three-phase meter. Along with that, some protective equipment. Either it may be fuse carrier, then LCD. From that, outgoing will go to the DB, distribution box. This line, this incoming connection is called submains. In apartment and all, that one particular apartment, from that DB connection, it will start from the basement.
They have standard rules. While you are submitting the drawing itself, where the EB boxes should be there, you have to specify it.
From the basement, we have one big meter panel. In that, every meter is included. From that, the circuit will go on to the DB. That is called submain. Okay. Then from the DB, then I will tell what are the components inside DB. Those components will come inside. MCB, then RCCB. If ELCB required, then we need to include ELCB. See, first we will connect RCCB along with ELCB. So incoming circuit will go into RCCB, the outgoing will connect it to the ELCB, then MCB. MCB is as per the requirements. If for AC circuit is there, we need to connect, if it is 1 ton, 10 amps, 20 amps, MCB we need to connect. If it is more than 1 ton, some more than 20 amps, as per that requirement, we need to connect that MCBs. So first thing, that is RCCB. Second one, that is ELCB if required, then followed by MCB. From these MCBs, we will connect to the switch box. So that is called incoming circuit. Incoming circuit for this particular switch control. See, in residential, we will use 2.5 square mm incoming circuit for lighting. Okay. Then 4 square mm circuit main for power equipments. What are the power equipments? Mixie, grinder, oven, then that kind of thing. So we will put 4 square mm for incoming for that circuit, that specific equipment. Then 2.5 square mm wires we will use for lighting. See, fan, tube light, these are all comes under lighting circuit. Then AC, fridge, mixie, microwave oven, all this comes in power circuit. So two type of circuit will be there in the residential building. Okay. See, from this MCB, we will connect one lighting main or power main to the switch control. We will call it switch box. In that, lot of switches will be placed. Okay. From that switch, each and every switch, we will connect light or fan or something. What are the equipments we need to connect? We will calculate accordingly. Okay. Then, I told 3 kilowatt meter is using inside meter box. How we are calculating? If it is 3 kilowatt or 5 kilowatt or 7 kilowatt, how we will calculate? Any idea? Not number of rows. Number of equipments we are connecting to one particular circuit. See, fan 60 watts, tube light 40 watts. These watts, no, that P. That P we will calculate. Total loads, total number of loads, we will calculate. We will calculate, the final stage will be that 2.5 kilowatt or something we will get the total load. As per that, we will calculate the meter. 3 kilowatt or 5 kilowatt, we will calculate the rating of that meter. So, then we will see how they can consult them. We will select one wire. How 2.5, 4 square mm, 6 square mm, how they are calculating. So, they know the number, power of that particular area. Then voltage we know 230 volt for single phase. Then current, this factor we don't know, this factor also we know. Power we know. Then we can calculate the I. How much ampere one circuit need to carry. Okay, the architect or consultant, they will calculate the I. As per current rating, he will select the wires. Okay, as per that current rating. If it is 6 amps, if it is 9 amps, 10 amps, as per that current calculation, he will select wires. Okay, these are all the things in that apartment or villa.
These are the design consideration and the execution consideration. What are the things? How the execution, the civil engineer and the electrical engineer will coordinate. That he will explain in the next this thing. These are design consideration.
You should know the SLD. What is SLD? Single line diagram. In this kind of execution, they will consultant will give drawings like SLD, then lighting layout, power layout, dimension layout. Lighting layout in the sense, in lighting layout, they will mention the points wherever that light is coming, fan, tube light, that kind of thing. They will specify inside lighting layout. In power layout, what are the power equipments need to connect? That they will include. Then dimension.
And where the box needs to be fixed also they will give you. All the details will be given in your electrical drawings and the plumbing drawings. Electrical will be given in the electrical drawings and the plumbing items will be in the plumbing drawing. There will be civil drawing, architectural, structural drawing, architectural drawing, electrical, plumbing, everything you need to read before execution.
That is called coordination. Coordination between MEPOs. So, lighting layout, that symbols, lighting symbols, where and all, what are all the points we need to connect, that will comes in lighting circuit. Power layout, we will see the power equipments. What are the requirement inside that one building. In dimension layout, they will specify all the measurements. For example, tube light, how much height from FFL.
What is FFL? Floor finish level. Correct.
From the FFL, what is the height of that point? From the corner of one building, what is the...
They can't, electrician can't fix on their own these things. In the drawings, whatever mentioned over there, as per the drawings only they need to fix. If it is not being fixed as per the drawing, the electrical engineer will come, he will check and he will tell, this is not correct. You have to redo the things.
Next, sequence of work. In electrical, what are all the sequence we need to follow? You know the first sequence. Consider one building, an apartment or residential building. In that first sequence of work is roof continuity. Remember the technical word, only technical word.
Yesterday you have seen, we have considered in your MS project also, where the electrical person also has to come and he has to lay the pipes and all. Then the other activity will carry. Before concreting, the conduits needs to be laid. That will be done by the electrical vendor or electrical engineer. He will approve the things. Sir, this is as per the drawing. I have executed all the pipeline, the fan point, light point, everything. Whatever comes under the ceiling, he will do it. And before the plastering also, he will come into the picture. All the boxes are properly fixed. The size of the box is correct. The conduits are fixed properly. How many number of the conduits? Because you can't do after the plastering, you can't remove and put the pipes. After flooring, you can't remove the flooring and put the pipes. In each state, the electrical, civil, mechanical, plumbing, everyone will coordinate. They have their checklist in a project. The electrical, once they give the clearance, the plastering activity can go on. Otherwise, the plastering will be waiting until he certifies his work is completed. He has to wait. That coordination and all has to be done by site engineers, the particular block in charge or particular layout in charge, whoever is there, particular site engineer, he has to get all the clearance, coordinating with the electrical plumbing. That is his basic duty. If you are a site engineer for a block of 5 villas or 10 villas, on that your activity will be the coordination between the people. Yeah.
So first sequence work, that is roof continuity. After the reinforcement, we will lay the conduits, we will place JB means junction box. Line and out you reach JB. Then we will interconnect as per that drawing. From where the DB is located, where the switch box is located, as per that drawing we will lay the pipe. Because from that DB we need to connect to the metal box. Then from there we need to connect to the equipments. So as per that idea, as per that conduit layout, we will lay the pipe. That is called roof conduit. Then second thing, glue cutting.
How the glue cutting is done? Somebody has to mark it. Who will come and mark? Like survey, the mason will come and give the measurements and all. The engineer will check. Like this, electrician will do the marking. He will check as per the drawing it is there or not. Glue cutting.
Second thing, glue cutting, conduit and metal box fixing. That is the second sequence of work. As per the metal box location, we need to connect up to roof level. We line the pipe, so we need to connect it to the metal box. So we need to glue cut that area and we need to connect it to the metal box. So the second thing, glue cutting, conduit, metal box fixing. Okay. Actually, metal box fixing will come first. After that, only these points will come. Okay. Then third thing, wiring and switch plate fixing. Wiring, switch plate fixing and DB termination. And doing work completion in DB, we will call this DB termination. Termination work. That means connections.
They will also get the payment simultaneously. If one work is the conduiting work is completed, they will get the conduiting payment. Like that, the electrical people also need money. As per the activity, they have their own activity. As per each and every activity, they will raise the invoice for the billing. They also have BOQ. As civil person, you are having a BOQ, bill of quantities. For example, lintel is completed, you will raise the invoice for lintel. My lintel work is completed. Like that, the electrical engineer will raise the electrical bills. Okay.
Wiring, switch plate fixing.
And plumbing engineer also raises same.
The last thing is testing and commissioning. For every MEP works, the final stage is testing and commissioning. In that
is the important phase, testing and commissioning.
So fixing of one diesel generator we will call as erection of DG, erection of street light poles and erection of panels. After completing all the work, termination work, we need to do testing and commissioning. Then some various testing and commissioning process methodologies are there that I will explain. Okay. So you are familiar. In wiring steps, after this metal box fixing, glue cutting, conduits, we will get the clearance and we will start the wiring. After wiring, switch plate fixing, DB dressing, everything we will complete. Then we need to go for testing and commissioning. That is the final step. After testing and commissioning, it's ready to hand over. Hand over to the, if I am a contractor, I need to hand over to the PMC. So if I am a builder or something, we need to hand over to the customer. So after testing and commissioning, you will get the idea. If some mistakes are there, we need to troubleshoot. You know the term troubleshoot, right? Troubleshoot in the sense some mistakes are there, we need to rectify. As an engineer, we can't do it. We need to suggest what are all the steps you need to follow. Electricians, what are all the steps to follow. So we need to suggest some ideas. That is called troubleshooting. Every sector we are using this word, troubleshooting. In projects, in maintenance, in oil and gas, every industry, the troubleshooting will come. Even in IT industry, troubleshooting in the sense we need to rectify that problem. So everything will finish. So in this area, do you have any doubt? Just ask.
Sir, off ಮಾಡಿ ಸರ್.